In this example, we're going to revisit the concept of multiple selection. Now, earlier in the preceding lesson, we introduced nested if-else statements, which is one way to select from multiple courses of action. In a switch statement, what you're going to do is use a controlling expression's value to compare against a bunch of so-called cases to determine what to do. And for the purpose of this example, we'll be working with the letter grades project in the figure 06_09 folder. And as you're going to see when I run this right now, the program inputs from the user a bunch of integer values representing grades, and it increments counters that represent how many A grades were entered, B grades, C grades, D grades, and F grades as well. So I'm going to type in the value 99, and the program will then figure out is that an A, B, C, D, or F, and increment the appropriate counter. Now 99 would be an A, as would 92. 45 would be an F, as would 57. 63 would be a D. 71 would be a C. Let's do another C as 76 here. 85 would be a B, and let's go ahead and throw in a couple of additional A's as well. So we've entered a bunch of grades here, and as I've been entering those, the program is processing and incrementing the appropriate counters. Now when I type Control Z in Windows, it displays this caret character followed by a Z, and then when I press Enter, that control sequence, if you will, gets submitted to the program to tell it to terminate the iteration and processing of the grades. At that point, we display a little grade report where we show you the total of the 10 grades that, in this case, I entered. This is a Sentinel controlled loop, by the way, so I could enter fewer or more grades if I wanted to. We're calculating the class average, kind of like what we did in an earlier example in the preceding lesson. And we're also displaying how many of each letter grade were entered. So we had 4 A's, which were, going back up above here, 99, 92, 90, and 100. We had 1 B, which was 85. We had 2 C's, which were the 71 and 76. And then we had 2 F's, which were the 45 and 57. So let's go ahead and take a look at the code that helped us achieve that. So again, we're dealing with a simple class in which everything is done within the main method for this example. And we have several integer variables. We've got the integer called total, which stores the total of all the grades that get input. We have the integer called grade counter, which keeps track of the total number of grades that were entered. We also have counters representing the number of A's, B's, C's, D's, and F's, all of which are initialized to 0 to start out because we have not yet input any grades. We then prompt the user to enter the integer grades in the range 0 to 100, and we have them type Control Z and press Enter to terminate the input. We then begin our Sentinel controlled loop. Now, you may recall from the preceding lesson that with Sentinel controlled repetition, it's common to perform input before the loop so that you can then check for the Sentinel value. So when I say console.readLine, that says to read a line of text, and normally that's going to give me back the string of input, the string of characters that the user typed. However, if the user types Control Z, readLine will not read anything and instead will return a null reference. So at line 21, we assign to input whatever the user typed and stored in the string variable input. And if input after that line of code is equal to null, that would mean the user said stop receiving grades and display the grade report. So if input is not equal to null, we will then take that grade that was input and turn it into an integer. We'll add that grade to the total, and we'll increment the grade counter to say that we just read in 1 grade. Next, we'll divide that grade by 10 to figure out if it's an A, B, C, D, or F. Let me scroll down a little bit here to show you the entire switch statement. And you can see here, this is our so-called controlling expression. The value of that is going to be compared with the various cases that you see listed in the switch statement here. So first, we have 2 cases that represent the grade A. If after dividing the grade by 10, we get the value 9 or the value 10, we're going to increment A count. So think about that for a moment. If the grade is 90 and we divide it by 10, the result is 9, and we're going to increment A count. If the grade is 91 and we divide it by 10, grade is an integer and 10 is an integer, so the result would normally be 9.1, but it's only going to be 9 because the floating point part gets truncated. So for any value from 90 to 99, dividing by 10 is going to result in a match with the case 9. And if it's 100, which is the maximum grade, divided by 10, that will give me the case 10. When you want to perform the same statements for several cases, you list each individual case followed by its own colon. You can list them vertically as we did here in lines 33 and 34, or you can list them all on one line as case 9 colon, case 10 colon, etc. Now, after we increment the A count here to say that we got an A grade, we then execute a break statement. Now, this is one place where C# differs from other C-based programming languages. In C#, this break statement is required after the statements for a particular case. This forces us to jump from the break statement to the closing curly brace of the switch and move on to the next statement in sequence. Unlike C, C++, and Java in particular, there is no so-called fall-through from one case to the next, with the only exception being when you list multiple cases like this in a row with no intervening statements of any kind. Once you start executing any statements, you must have a break statement, and the switch then terminates at that point. If you want to get the effect of falling through to another set of statements within a different case, you could use what is known as the goto case statement, and the syntax of that is goto case and then the value that you're testing for. So I could say go to case 8, and that would say after incrementing the A count, I also want to execute the statements for case 8. And notice we're now getting a squiggly line here indicating unreachable code, and that's because once we jump from line 36 down to line 38, line 37 would never execute. So let me go ahead and get rid of that to put the code back the way it was. So if the grade is either 90 through 100, then we're going to have either 9 or 10 as the matching case, and we'll increment the A count. If the grade is 80 through 89, any one of those values divided by 10 is going to result in 8, and we'll increment the B count. Similarly, 70 to 79 would match case 7 and increment the C count. 60 to 69 would match case 6 and increment the D count. Now, at the end here, we have the so-called default case. And that's not required in a switch statement, but it's often a good practice to provide it. In this example, we're assuming that anything that does not result in cases 6, 7, 8, 9, or 10 is a failing grade. And for that purpose, we're going to increment the F count in this example. And the break, again, is required even in the default case, even if it's the last case in the switch statement. Now, after the switch statement executes and increments one of the counters, we then do our next input before we reach the closing curly brace of the while loop, so that the user now has an opportunity to either enter the next grade or type Control-Z and press Enter to terminate the input. At that point, we go back up to the top. We check to see whether input is still not equal to null. If it's not, then we have another valid grade to process, and we do the body of the while loop. Otherwise, we jump all the way down to the bottom of the program where we display our grade report information. Now, if the grade counter is not equal to 0, then we know the user entered at least one grade. So just like we did in an example back in the preceding lesson, we calculate the total divided by the grade counter, and we're forcing this once again to be a floating point calculation. We could have eliminated the double cast operator here simply by declaring total as a double rather than an int. So we calculate the average. Then we display the total of how many grades there were and what that total was. We show you what the class average was, again formatted with the F specifier, which gives us 2 digits to the right of the decimal point by default in the US locale. And then we finally display the number of A's, B's, C's, D's, and F's that were counted. On the other hand, if grade counter was equal to 0, we will simply display no grades were entered.